rebuild and then run.
Okay.
And then we drag this over a little bit and look at all of the outputs. So the last section we see, because of one of the two conditions presented in the evaluation of the if is true, we see the outputs. So one is greater than 0, which is true, and then one is less than 0, that is false. So because one of these two conditions is true, the overall evaluation, or the greater evaluation, is true because of the way that a logical OR works. So right here, we have if 1 is less than 2, or 1 is equal to 1. Again, because one of these, or both of these are true, 1 is less than 2 and 1 is equal to 1, it is still true. With a logical OR, only one condition in the greater evaluation has to be true for the entire evaluation to be true. And then on this last one, 0 is less than 1 and 2 is less, 0 is greater than 1 and 2 is greater than 3. Both of these are false, so we will end up not seeing this last little bit of output. Now, if we wanted to see the AND example of that to kind of understand the difference, we'll do if 1 is less than 2,
one of the true statements is going to run,
and then AND
inside there.
0 is less than 1.
So those are false. Great, good enough.
Because both conditions in the evaluation are true, we will see this output. And then if we were to do one of them being false, so if 1 is greater than 2,
very nice,
and
perfect syntax, no need to change it.
1 is less than 3. The conditions ultimately don't matter. It's just we have showing that 1 is false, 1's going to end up being false, 1 is true. So with a logical AND, if any are false, the evaluation is false.
Wait. Blows. So I just won't run? Okay. Alright. Gotcha. Okay, hold on. That's actually important information. Jeez. All of it's important information. I just need to know how to categorize it as important.
Then, before running it, we can add another line.
But we're learning.
And rebuild. Run it.
What was utility line?
And we see both were true for the logical and, so we see this, and we do not see that we won't see this because one of the two conditions are false. So with an OR, any of the chained expressions or conditions inside of a singular evaluation, one of them can be true, and then the evaluation becomes true. With logical and, if any of the chained conditions or expressions end up being false, the evaluation will be false. We have any questions on that before we go to nesting?
I suppose if I need to, I'll ask him the next stream how to get past utility. Okay, switch case, we actually need that one. We definitely need that one for sure. And enum, I don't even know where to start with that one. Nesting, we kind of have an idea of it. Yes. I really just don't want to use AI because, you know, it defeats the whole purpose of the class.
Okay. Going to nesting, we're going to use the same
really don't want to, but sometimes you get
thing we saw on the slide, so we're going to continue age and register to vote.
The boundaries.
So with nesting,
but moral conduct.
This is
follow moral conduct.
all about placing blocks of code within blocks of code.
Right.
It can also make conditions, ifs, way easier to read instead of chaining conditions to a singular evaluation or making a long tree based on separated conditions.
That's not good.
So if we follow the example from the slides, we start with if age is greater than or equal to 18.
Temptation. That's good enemy. I'm gonna lie. I'm gonna do it. Okay, so here we are. We're at a basic if statement. We already know this stuff. But for good practice, we're just going to close this. I don't know what the proper way is to go about.
And then we can put it in the else, just for good measure, so we don't forget to do it later on.
Close out. I wonder if there's like a...
And I'm placing notes on the scope braces so we can keep track of what's what, so it's easier to understand as we write this. If need be, I will also space some stuff out. So if age is equal to, greater than or equal to 18. So we'll start with cout, age is greater than or equal to 18. And then we can have our first nested if, checking on the value of register to vote. Assuming register to vote does not equal true, this block runs.
Perfect. Now we're just gonna...
We add our if statement on the inner if, so inner if false, inner if false.
I also want to ask him about this portion, the save file as.
So here,
like, I want to do multiple versions in the same folder.
Register to vote is not equal true, we're going to assign register to vote.
But we're just going to not do it there because I think that's our one personal.
The return of the register to vote method. So again, kind of like what we did up here. This line right here. We're basically separating all of the conditions into their own thing. So the
perfect
else portion of this inner if is assuming that any other value for register to vote would then go be placed in the else effectively. So if register to vote is true, because it can only ever be false or true because it's a bool, and we're checking to see if it is not true. And so note on that. The other way to write this is if register to vote equals false. So this and this, in the case of a bool, is effectively the same line. Since we're testing for it not being true, the else is if it is true, we're going to run vote.
I want to ask him if he can like help me with a personal console application project, so like I can like take a step out of Lab 4 for a moment and kind of like start from scratch and then help me.
And then we're going to hop back out to the outer else. Again, noting that the outer if is on age, so if age is greater than or equal to 18, the else would be if it's not greater than or equal to 18, so 17 or less. we can then run this after. Let's see, we have a line there. We'll put a line under this.
Oh.
We will rebuild. And then run, and note that I have not altered the value of age or register to vote, so age is still 17 and register to vote, I believe, is false. And unlike the prior example where when we were looking at not nesting, but just an if else if tree, we only get the one output because we are separating the conditions and nesting anything else that we need to check. So we're first checking age. So if age is 18 or greater, we then go into the block that would have the if register to vote. But because age is 17, so not 18 or greater, we get the else. And it's you have to wait until you're 18 to register to vote and to vote. So now,
perfect.
If we want to see the other outputs, we're going to alter age to 18 and register to vote to false, once more back to its default values. And a question from online, what exactly is utility line doing? We're just going to scroll up to its declaration. All it does is output a line for easier to read output. So
yes.
It's what's generating these lines.
Okay, hold on. Let's add that. We need that. All right. We lied.
Okay. So after altering the values of age and register to vote once more, we're going to rebuild.
Temptation.
Scroll to the bottom. We see age is greater than or equal to 18.
Actually, hold on.
And we don't see anything else. The reason why we saw something else in the other example of this is...
We'll catch up.
Because I believe I put a line in here saying you registered to vote. So if we wanted to see output for that, I could either add that to the method itself, which I will, so I can remove the other line. Let's see, so we're going to go to the register to vote method. We're going to go above the return statement because if we put it below the return statement, it won't happen.
No, tell me this works. Oh, this is lovely. Hold on. Interesting. Okay, so it doesn't work. We're figuring things out. Okay, so I guess it's gotta be in the actual what you named it.
And then we can scroll back down to our initial example where I had that line.
AI that if I wanted to.
We could then remove it, and we would still see it because I added it to the register to vote method. And now if I rerun after rebuilding and not altering the value of age or register to vote, we should now see that you registered to vote text right here. So we see age is greater than or equal to 18 on top. We see that because the condition evaluated to true. We then go into the inner if, where if registered to vote does not equal true, registered to vote equals false currently. So we run the register to vote method, which sets it to true and gives us the output of you registered to vote. We don't see the else because this is true. And we don't see this else because the age is 18 or greater. Now, if I change the value of registered to vote to be true, we should now see the output for age is greater than or equal to 18. And I believe it was you voted or you vote or something like that as part of the vote method. So we're going to rebuild and then run. And it says you voted after age is greater than or equal to 18. It's also good to note, I'm going to put this as a note as well. So you can continue to nest ad nauseum, ad infinitum, however you want to say it. You can continually nest to your heart's desire. So I am going to make a comment to kind of show that. We're not going to go through an example of that, but to kind of see what it would look like.
What's up? Oh, you're fine.
Should you want, and then you could also nest in any of these else's, and then continue nesting however you see fit.
No, this.
Generally not good practice to do this, as there are better ways to eventually do this.
Or something like that.
But I can tell you, a good example of something very similar to this is if you've played Undertale. Undertale's dialogue options, they're not a giant if tree, they are a giant, or they were, I don't know if he's fixed it yet, a giant switch case.
Open?
So based on the room, based on your decisions,
I thought it was just a normal
certain outputs are derived from like this 1,000-line long switch case.
He's got symbolism in that.
I know.
Like,
He was amazing.
I'm impressed. I was.
The lawyer was amazing.
Say again? Yeah. Yeah, it doesn't surprise me. A lot of those games, they end up being like that.
Oh, what were we? Oh, gosh. Right.
Mm-hmm. You can definitely do that, and like I said, it's not best practice, but like if it's a lot of people who make games like that or make games like Five Nights at Freddy's, if you look at the game dev, like the list of that developer, his game list is exceedingly large, and they're not big games. They're all things that these developers are doing to learn their skill set so they can make something bigger and greater, effectively. So, like, even though it's not the best coded thing on the planet, it's still probably, like, if I were to look it up on Steam, it probably has at least good reviews. People are going to end up liking it, end up buying it, if that's, like, the type of game and genre they like. And he's going to go through and, like, use the knowledge he gained from that, go into the next game, go into the next game. Okay, so we have covered ifs in its entirety. Before we go into switches, are there any questions on ifs? Yep. So if we scroll back up, you see me do a lot of C-outs. Again, that's only so we can actually see the example run. But like in here, this if statement right here, there is a C-out in this method, the register to vote. But natively, like just what we see on screen right here, there is no C-out. I could nest here. I could put like variables here. Like I could declare int x, string y, bool yes. You can basically do whatever you want as long as it is correct syntax in a block of code. So just expanded question from earlier is, can we put more than two out statements in if? Answer is yes. You can put anything inside of a block / scope braces as long as the syntax is correct.
You wrote a paragraph.
Question from online is effectively wanting to learn without AI and work on a custom project, and if I would help on a custom project. The answer to that is yes. So if you have like something that you're working on outside of class, and it's a language that I can read and understand, just send me screenshots or send me a message or an email, and I can take a look at pretty much whatever you're working on and give you some feedback on it. And then as for the AI stuff, I could make a bunch of comments about generative AI where it's not going away. As a student, especially in this class, the only reason I would encourage you to utilize it is for explanation on topics, keywords, etc. So as a real-world example, one of my side gigs is I do small development on the side for a couple of friends who like to make random products. One of those products happens to be a generative AI product that its intended purpose is to do dream interpretation in 3 different styles as the creator specifies. And basically how I went about doing that in the simplest way is used Python, used GPT, had it create the framework of the project, and then I filled in the blanks and fixed all the code. So GPT 100% can generate code. A lot of the times it is going to come out broken, and you're going to have to fix it. That's part of the reason why all of us say not to use generative AI in your work, because a lot of the time it's going to come out broken, and if you don't know how to fix it, it's going to remain broken. That's one of the many reasons why we just discourage generative AI in general. Is it a tool that can be used to help explain things? 100%. Don't use it as a crutch, because the other portion of that is if you do a lot of research into generative AI, there's a lot of research out there right now where if it is your crutch, like you're leaning on it heavily, there is research out there right now that shows that it is degenerating or lessening the critical thinking skills of people who use it as it's basically the solve all, do all your work for you type thing. So that's another reason. But like I said, it is a tool that it can explain things to you in a different way. So if something I say, Doug says, Carrie says, any of the other instructors, if it doesn't make sense to you, you can get the AI overview from Google or any of the other ones to get you to explain something, or just go to Reddit or Stack Overflow, or ask any in the PG1 discussion. Anyway, going into switch case. So switches are very similar to if statements, but they cannot check conditions. They can only check values or a range of values. Similarly,
I mean, he says it's fine.
I don't think I
He says it's fine. All right.
It
Instructor
cannot
says it's not cheating, so
be used
I'm going
for
to do it.
non-numeric types, i.e. string.
Actually, what was it? Geeks.
So
geeks.
if we do a base example of switch, so we're going to make an int called my number. We're going to set it to 3. And then we're going to create a switch on my number.
I need the fastest way right now to understand.
And then, so this is effectively similar to if my number, and then we have our number of case statements, however many that we want to make. We can make as little or as many as we want. I'm going to say case 0.
Was it
case
static?
1.
Geeks for geeks.
Case 2.
C++.
Case 3. And then default. So this effectively is the same as if my number is equal to 0, or my number is equal to 1, or my number is equal to 2, or my number is equal to 3, or the default being the catch-all.
Brother. Okay. Let's turn him. How do I turn him down? I have no idea. Hold up. Brother.
So I'm going to type out the cout of my number is 0, and I'm going to copy and paste that and put it into all of the cases. Actually, copy it. And then after I paste it into all of the cases and the default, I'm going to change it around just a little bit so it makes sense for the block that it's in.
I know how to do that.
So for 0, we leave it at 0. For 1, we change it to 1. 2.
Let's do this. Where's zoom at? Geeks for geeks, utility line, standard function, C++, yes, blah. Such as printing a line of dashes. Right, I know. Okay, so Jesus, I gotta go over this so many times. So there's utility line. Let's just put that first. I'm overthinking it. Utility line. Right. Okay, so let's put that down. CN name line am I doing that? page specifically wholly on this topic, bruh. Like, thank you. Right there it is. God, dude, it's so useful as a tool. Right, so we might as well just practice this. We'll just practice it all, everything we see, and we'll just keep duping the pages, whatever. Just keep making new application. I need to listen to him for a minute though.
Another switch. And then I'll find a variable that we want to switch on. We'll say age, just so we're not making more variables.
It's like I've already done this before, but I need to do it more. So it would be equals 2. String name.
And then, just so that I'm not writing out like 20 different cases, we're going to just say 17 and 18. We can scroll up real quick to where I
We
last
understand
changed
this. It's not
age.
complicated. We know what this is.
It's 18.
Brother, hold on. I need to wake myself up. I can't think.
And then I'm not going to put a default on this one. I'll make a note of that.
Putting that there.
Then we're going to rebuild and run. So we've seen now we have our third switch case. In case 2 of that one, we nest an if 1 is less than 2, which that happens because that's true. And then inside of that, we nest another switch on age, and we're only accounting for 17 or 18, and we're not putting a default. So in this language, we now know that defaults are optional. We do not have to place them. It may give us a warning. We do have 5 currently. And it's all about the earlier ifs. Question from online is, when is the end time for the stream? We're getting close to the end, so I think this is like one of the last comments I have. Yeah. So after this, we're going to see an enum with an if statement, see if anyone wants to review, and then do questions, and then lab 4 stuff. So back to the triple nested switch if switch. We get my number is 2.
Okay,
right here. We have no output inside of the if. We only have the switch inside of the if. So we're switching on age. And age has a value of 18, so we see the output for age is 18. We have any questions on switches or nesting or nesting between different types of decision-making code?
I gotta get coffee.
If not, we're going to go on to enum and then basically use one of our prior to enums that we made at the very beginning. So we're going to say if, let's say artist. No, we'll do games because I left that alone. Games is we'll say if 1 is equal to games And what's here's Diablo? It should be Diablo.
No, we just stood. We want to drink coffee. We want to go to sleep. So I want to take this easy. We're going to do this. We're going to wait our turn. We'll come back to this. And we're going to ask if doing something like...
2 should be... Night Rain.
This is okay. Then basically doing this. Like, because that's technically code snippets.
We're going to put in a line.
Right?
Then rebuild. And then run it.
I really don't want to have to ask this question.
And we see game selected was Diablo because 1 is equal to the numeric of Diablo. So if we scroll all the way to the top to wherever our enums are,
stick and chill.
here's the Storm is 0, Diablo is 1, that is 2, and Battle is 3. So you can mess around with the enums and push limits should you choose. Then, is there any review that people want to see? More on methods, conversions, parsing, casting, input-output types. Casting.
Okay. We'll wait. We're almost there. Okay. Let's wake ourselves up. Right, this is where we're at. See out.
Yep. Okay, so there's no escaping heaven. We make a car called cast this. We give it a value of capital. So put that in there. Initialize car identified. This to the value A. This line, 2 parts. We create an int called holds casted car. We then assign it, initialize really, because it's the same line. Type and then variable. The parentheses type is what the value of the variable to the right of it is getting cast to. So int cast this is casting the car value stored in cast this to an int value, which is 65. And because we're using it on the line where we are assigning holds casted car, holds casted car will contain the the casted value of cast this. Does that make sense?
Hold on. I forgot. God.
Other forms of casting, because I do this one often because we're going to eventually see a test where this is extremely relevant. Other forms of casting are from similar types to other similar types. Int x equals 3, long y equals long x.
Need to correct that. God.
You can always cast up freely, meaning that the value range of an int is much smaller than the value range of a long, so you can always store an int value in a long. You can sometimes cast down, but it really depends on the value of the initial variable that is getting cast. And what I mean by that is you can mostly cast down freely. So we're going to say long b, or I'm sorry, long b, and we're going to give it a small value like 1, 2, 3. Even though that we know that longs can contain some absurdly large number. We can then say int c equals int b. And this is mostly a free cast because the 1, 2, 3 is in the range of an int. Now, if we say b has something that exceeds the range of a int, so we're going to look up the value ranges real quick. Going to go to somewhere that I can just quickly see the range. So longs have this absurdly large number. We're going to look for the int. We're going to copy and paste this number, which is the maximum size of an int. We're going to set b, which is our long that we're working with, to this value, then copy it. Keyboard likes to act, so make sure we copy it. So that is the maximum value of an int. So if we add just one place, we've now exceeded the max range of an int. The cast will still happen. It will not error out. It will be effectively a logic error, and we're going to see some strange number after we output everything. So we have that output for the card int. We are going to do a output for all the rest. And then we can copy this line right here. And the very last number that we see is probably going to be something strange. So we'll do a line here. And we'll make sure there's a line above. There is, okay. Now we're going to rebuild and run it, and we can see the output. So we see 3 and 3 for the upcasting of an int x to a long y. We then see the downcasting of a long b to int c. We then assign b a number outside the maximum range of an int. and we cast that, and we get -1 on both, even though we have, let's see, that's hundreds, thousands. I think we're in billions, like 21 billion, I think.
Okay.
However, we have this as a long. This should fit in the range. So if we go back over to our browser, go over to long int, or see if they just have long by itself. This should default to long int, which this number is much greater than a int.
We're last.
So we shouldn't be seeing -1 on the initial value unless I mistyped. So we're going to check that real quick. We have our long B, and we're outputting B right here. So in this case, what I think I'm going to do is we're going to make a new variable. And we're going to call it long, and we're going to call it F. And at that point, we're going to change the casting of int F instead of int B. It's int F, and we're going to change the output from C to F. I'm sorry, we're going to leave C alone. We're going to change B to F.
Hold on. Pause.
And now we should see the proper number over here with whatever strange number over here. It'll probably still be -1.
Bad habit. We're learning.
We're going to rebuild
F. Long,
and run it and scroll down. So now we see the proper number that we have, and we see the casted value of -1 because this value exceeds the range of an int. So that's what I mean by you can sometimes cast down, but you can always cast up. Question from online is string to int and string to unsigned whatever are ways of parsing in C++. Essentially, yes. So those are the methods that we would use to convert or parse from one type to the other. So in this case, it's dictating string to something, so we're taking in a string, and we're converting it, we're forcing the conversion to whatever the last character is on that method. So stoi is string to int, or stod is string to double. So question on that, here in notes, string to int, string to double, parsing. Yes, these methods parse, convert from string to the targeted type. So we have string do a convert, and then we're going to have a int of, let's see, holds converted equaling stoi, and do a convert. This is the conversion of the passed argument.
These methods parse or convert from string to the targeted type
to an int value.
Do a string. Okay. So
and then same thing if we wanted to do a double version of that. So double holds converted double equals stod, or string to double. Do a convert. Forces conversion of the passed argument. Do a convert. Do a value. Okay. So before I open up Lab 4, do we have any questions or any other review we want to see?
I'm not ready for this. I'm coming last.
Okay, so before I open that, I'm going to make sure I save this. I'm also going to go through the example of compressing this again. So after we're done with the project, we're going to go over to Solution Explorer. We're going to right-click it. We're going to go to the very bottom, and we're going to look for Open Folder in File Explorer. It's going to open your File Explorer, open to the repository or the directory where the file you currently are in exists. So you see, we only have one source file that we've been working in, Day 4 Demo. if I open up the Day 4 demo folder, what was open to via Solution Explorer, and once again, I'll actually close this out, go through that process one more time. In Solution Explorer, right-click the project name, scroll down to Open Folder in File Explorer. It's going to open up the directory in which that file exists in. So right here, we're where our C++ file, our project files are, and some other stuff. We can also look at the path bar or the URL bar, whatever you want to call it. We can see that it's defaulted to tabs. If we click it, we can actually see the true path. It's going to be users, your username, source repos, your project name, and then probably again your project name. But what we want to do is, if we want to traverse the hierarchy of the project, this is our current folder we're in because we don't have anything to the right of it. So this is the parent directory. This is the directory we're in. So we're going to go up one level or up to the parent directory of what we're in. We can then see our solution file, the x64. If you have hidden files shown, you're going to see the .ds, and you're going to see the folder that you were just in highlighted if you were to click on the tab. So we're going to go back in it. So we're in what we opened initially from right-clicking the Solution Explorer and showing in File Explorer. So once more, right-click it, show project in File Explorer. We're in the initial directory where the C++ file's in. We go up one parent directory. It highlights what we were just in. This is still not what we want to compress. We have to go up one more parent directory, usually to repos. And it's going to highlight what we were just in. And the reason why I suggest going through this method is at some point, very soon, if you have all of your demo projects or regular projects that you're doing outside of school, if you default them to repos, this folder gets very big very quickly. As you saw me delete in Lecture 1, I deleted a ton of projects just so that we could have something clean to work with. It's already a little bit bloated because we're on day 4. We have 4 folders, day 1 through 4, and we have 3 zips, and we're about to make another. So we're going to right-click the project we were just in, go to compress, and zip. It's going to error out on you because I forgot to close, so first we have to close it. We then have to move this bar around and click cancel. That's going to end up canceling it all together. We can then, after it's closed, go to compress again and zip. And then it's going to generate the zip folder. And then you can drag and drop it wherever you need to be. So if it's your assignment, on FSF. If it's the live demo in which I'm doing, I'm about to put it on the PG1 announcements channel.
Let me see what this looks like.
Okay.
Should I?
Now, for Lab 4,
Interested.
I am going to grab a fresh copy of it. And I think there are questions on Lab 3 as well, and we'll get to that here in a moment. So I have Lab 3 open so far, and then I am going to week 2 for Lab 4. I'm going to scroll down to the downloads and download that real quick. And then, let me check chat.
And that. Come over here. Close that. Come over here. Close that. Where's my zoom at?
Question effectively is, could I use Geeks for Geeks source and show me the proper use, like when I'm researching? So before we jump into the labs, I'll actually do that real quick.
Perfect.
So when you are doing outside research and you're basically Googling or using whatever search engine that you want to, excuse me, and you want to look for something specific. So if we're talking about, let's use a basic example of cout. So this is how I look for things when I can't remember the syntax in the language that I'm working for or working in. I start with the language and then the thing I want to know what the syntax or what I want to know more about is.
Okay.
So we're going to press enter on that. If we're on Google or probably even Yahoo or any other search engine, you're probably going to get some AI overview.
I don't like
for
that.
the most part, they do have good in-depth explanations, but a lot of the time it could either be extra stuff that could be outside of the scope of the course. So like if we were to look at this one, it breaks down namespace. It gives you an explanation of it slightly, but we know that we can't use the namespace directly in this course, along with like a bunch of other methods that we just don't talk about in this course, like fixed or set precision or set W or set F. So it gives you a bunch of examples that we just don't use. And you basically have to remember or look at your notes. Hey, this doesn't look familiar. Check my notes. Oh, it's not in my notes. Check, like skim through the video. Oh, it's not in the video. I probably shouldn't use this. But if we're not looking at the AI overview, let's go to like Geeks for Geeks or, what was it? Yeah, Geeks for Geeks was the actual example used in the question. To parse most websites, like for Geeks for Geeks or Tutorials Point, you're going to get a decent paragraph or three about what you were looking up. You're going to get an example. So right here, we have IOStream, which is required for CN and cout statements. We have using namespace right here, which again, not eligible for use in this course. Basically what it does is if we look down into the main of this example, we do not see the prepend of the standard library. It basically removes the need to type that, but it's not best practice to use. Yeah. If they're in, is the video made by like Doug Arley? If the video, it shows in the video for the most part, it should be used. However, we are under the process of updating all of the course material. And as it evolves, it's just a very slow process of getting all of the videos updated because we basically have to re-record the entire thing and edit it. So like a good example is static cast. So months prior, I think it's like 3 or 4 now, static cast, which is another way to just cast a value to another type, was eligible for use, but we're going away from that. So you may see examples of stuff like that, or the this keyword when we get to lecture 7 or lecture 8, or
okay, let's see.
If you see it in the video and it was from Doug Arley, I'm not going to count it against you, or if it's from any of the other instructors on Full Sail. But just know that things like static cast or like the this keyword aren't eligible for use. Best practice, check the FAQ on Discord, because that's where a lot of the live material of do's and don'ts exist. But back to this. For a simple cout statement, we're probably not going to get much more outside of the scope of this course besides using namespace as standard library. We can just see cout as an example. Now, if we were to look up if statements, for example. Again, we're going to get the AI overview. We get, the pseudocode example that we saw in the slides, and then we get a breakdown of the operators that we can use, everything that we saw. And so far, nothing that is outside the, actually nothing that's outside the course of the scope of the course. So that's actually pretty good. But like if we check a different website now, like W3 Schools, we're gonna get a base explanation of everything, and then syntax example, and then an actual example like what I was doing in slides, if 20, is greater than 18, and then a C out of it. And the only external factor in this case is the implication of using namespace because it does not have standard library prepended here. Also on W3 schools, it has a live editor that you can test your projects or test your code in if you want to play with a live editor online like this. So if we were to remove the user namespace that we assumed was there, actually remove it for your phone, but that's us. We would then have to prepend standard library there.
Hold on.
It's going to run. It's going to take a moment for it to do its thing, and we can change whatever we want. But let me go through this one more time.
See, W3 schools. I did that? Oh, okay. I guess I'm gonna have to.
So next little bit from online is the hashtag pragma. We don't really cover it a lot in this course. Just know that it exists, and if for some reason it is missing and you get an error on it, just let me know. And if it is missing, there could be instructions to add it somewhere. But when you're making your own files, which you generally don't have to do, I believe, in the vast majority of labs, you don't really have to worry about it. Once you do create your own files, so like if I were to go over here, we'll actually reopen the day 4 demo. There it is.
Right. Oh shit. Speaking of which, let's just save that.
So
Close that.
that's the broken one. Go to the non-broken one.
Okay, so this is what they gave us, basically.
So we can see that we have
Nice
exactly
solution.
one file in this project, the day4demo.c++. If I were to add another class file, so we're going to go to project, add class. I'm going to say example. This is day 7, day 8 stuff, but this is how we're going to see the actual pragma keyword or the preprocessor for pragma. So it's going to auto-generate using this wizard, the name the class example. It's going to generate a header file and a C++ file. We click OK. It does its thing.
Pragma 1's right.
We see pragma once here. This is the header file, which by default will exist in the header folder. And then it also generates the C++ file, which is going to automatically include the header file inside of it. So pragma once, I don't have the exact definition of what it is offhand. We'll Google it here in a minute. This is something that I have generally only seen in C++, and I have let it be. So we can look it up what it means. C++. What is pragma? Let's see, non-standard preprocessor directive used in C++ header files to ensure that the file is included only once. Okay, so what that means is this is like heavy day 7, day 8 material. When we're doing includes, like we're including IOStream, IOString, or I'm sorry, the string. Once we start creating our own files, we have to include them in other files for them to be used. The pragma once ensures that it is only included once, because if you include a file multiple times, it is going to treat the file as if it is a new entity. So if I say include example multiple times across files, it could and more than likely will cause errors, but the pragma once makes it only so it is included once. Okay, so we are going to start with lab 3. I think somebody had a question on it. Scroll up. Gabriel, if you are still there, what is your questions on lab 3? Or anyone else if you have questions on lab 3. Not to call, but to create. Yeah. You 100% are. I've shown you static. I've shown you void. Just make sure, like, if the instructions, so, like, if we look at test 6 on lab 3 as a good example, like creating the concat method, it says create a method named concat and return the value of all 3 parameters combined to form a question. So we have 3 parameters. We know the types. String, you can name them whatever you want as long as they're, proper naming convention. We know that the return type is string, so it couldn't be void. If we go down to 7, the return type is going to be float. If we go to 8, the return type is double. 9 is a double as well, and test 10 is a double. So ultimately, you're not going to be creating a void method in lab 3, but you are 100% going to use the static. Okay, Gabriel's question is about understanding the concept of type conversion in test 7. So we are going to look at test 7.
Actually, I just want to see what's going on with test 7. That's actually a good thing. I'm glad they asked that. I get to see what's going on in the
so
future.
it's part 2, part 1. Okay.
For Manus.
So test 7, part 1 is you're going to create a method named convert and return the value of the double parameter converted to a float using a cast. So we're not going to use anything like string to int or string to double, string to float. It's specifically asking for a cast. So it's going to be something similar to, going back to the demo, going to the file, and scrolling down. It is going to be something along the lines of this.
Utility
like
line. We're going to
casting
look that
from
up later on Geeks
an
for
int
Geeks.
to a long, or a long to an in, or a car to an in, or an int to a car. So going back over to the lab, return the value of the double parameter converted to a float using cast. So we know that the parameter of the convert method that we are asking you to create is going to be a double. And we want you to cast it to a float. And after you make that method and do the cast, inside of the test 7 method, you are going to call your the method that you created. And keep in mind that the naming specifications on what we ask you to create is case sensitive, and it must be, basically what we provide. So it can't be a lowercase c convert. It cannot be conversion, lower c or lower, upper c on that. It has to be basically the name that we provide, because that's what our background code is going to be checking for. So after you create a method where you're casting the parameter to a float and returning that value, you call the method over here in test 7, and you're going to return the call of that method. So effectively, what that'll look like, because I've already shown it as an example in day 3 demo, it'll be whatever you choose to call the method.
Okay.
And in this case, we directly tell you what the method's name is going to be.
Test
and then
7.
all you have to do, the bulk of the work is going to be in all of the other helper methods. So in test 7, it's convert. In test 6, it is concat. In test 8, it is average. In test 9, it is area. And in test 10, it is overloading test 2. So based on that, do you have any other questions about test 7? Okay. So for test 4, you go back to the note that I put down here. It's what, test 1, test 4 of lab 4. We're going to go over to downloads.
That's fine. I can ignore that for now.
Again, after we have downloaded lab 4, we have to extract it. We get the extraction wizard. it's going to default to the same path to where the zip
No more
file is.
questions,
So in my
Richard,
case,
in the
it's in
stream.
downloads. We extract it. We're going to open it up. And we're going to look at test 1 and test 4. Also, before I forget, because I got a question on this yesterday, if your project opens and you don't see code, you don't see the Solution Explorer, go to View, Solution Explorer, look for the student to do. You're going to see generally one file. Later on, you'll see more. But in this case, you'll have studentwork.h. After going through all of the comments is when I would recommend start tackling the test. And then test 1 says proven or denied. So that's the name of the test. So we're using a condition statement or a decision statement to check the parameter and return the string proven or the string denied based on comparison. So we give you one parameter called input, and it's typed bool. The objective is to return a string, and based on the above comments, we're either returning the string proven or the string denied. Example input is bool has a value of true. The expected output is going to be the string proven. So looking at the structure of test 1, we can see that it has a string return type. It's identified as test 1. It is has a bool parameter called input, so corresponds to everything that we saw in the comments. It is your job to, based on the value of input, note input is a bool, so it is only false or true. You'll return a string value of true, of proven or denied. This is also a really good section because this is the first part where you might be tempted to use multiple returns. Maybe not specifically on this, excuse me, this test. So I'm going to actually demonstrate how to get around using multiple returns in this case, because it is a 10% point reduction on the project if any of these tests have more than one return. So, kind of like we were talking about in day 3, the live demo, we have to check the return type of the method, and we're going to create a placeholder variable that shares that type. So, return type is string. We're going to create a string. We can name it pretty much whatever we want. I'm going to call it placeholder. I'm going to give it a default value. Default value also doesn't matter. Depending on your decision-making code, you're going to alter the value of this placeholder variable, and then you'll end up returning that placeholder variable. So that is the true and tried way to avoid using multiple returns. Set up a placeholder variable. Again, does not matter what you name it. Just make sure that the type matches the return type of the method. And then use that variable in whatever you are asked to do, alter its value, and then end up returning that variable. So if we look at test 2, test 2 has a double return type. We're going to create a double variable called placeholder. Give it a default value of 0.0. Not even looking at the comments of test 2 or the instructions of test 2 yet, we are going to return placeholder. And so on and so forth. So test 3 has a car return type, so we would make a car placeholder variable, end up returning that. Test 4, the other one that I was asked to look at specifically, let's see, test 4 is about leap years. Using a condition statement to determine if the year is a leap year or not, return the resulting value. So there's going to be one parameter. It's going to be an int called year. You're going to be returning a bool, so only true or false. And the example is going to be 1979 is the example value of year, and the example output is going to be false. So not a lot to go on there. for leap year purposes, like calculating if something is a leap year. But if we go down further to the tip,
Was it what? Was it
a leap year is a year divisible by 4, but not divisible by 100. However, years divisible by 400 are also considered to be leap years. So you're going to write, ideally, unless like you can do this in your head, I know I can't. I would be writing like all of these statements down on a piece of paper and like trying to figure out effectively the math to go behind it and how we're going to chain effectively the conditions that are going to go about this. So we know that a leap year is divisible by 4, divisible by 400, but not divisible by 100. So we have 3 base conditions that we have already to denote what is a leap year. We're also assuming divisible with no remainder is the assumption here. So we're not modding anything, or we shouldn't be modding anything, just divisible by 4. I mean, you could use mod as a check here, and I think some people have done that as to help them get to the answer. But what I would recommend, honestly, for this one is to write out your thought process, and then after you write it out, try and throw it in code and go from there. We have any other questions on Lab 4?
But he also said, hold on.
Are you talking about like when you turn in the zip file? Technically yes, but no. Because the way that I download everyone's assignment, I download them all at once, so they're already in a folder that is named you. So I know whose is whose effectively. With the leap years, 100%, you're doing a lot of math. Because you have to determine whether the given year that we give, so int year, going to represent a whole number that contextually is a year. And then you have to determine whether it's a leap year or not via, is it divisible by 4? Is it not divisible by 100? Is it divisible by 400? If there are no other questions, you all are free to go, grab some lunch, dinner, whatever. Lab back here for campus students at 5:30. For online students, look for the announcement on the PG1 announcements channel that Amara, Kevin, or Phil will put up. And I will see you all on Friday.
Alright. We're just gonna leave meeting. Use the condition statement. Condition. Okay. Alright. We're gonna start right there. We're starting straight from scratch. Okay. I want to use space CPP. Right here. No. Let's not overdo it. Okay. Sure, brother, sure. I'm gonna be here a lot. Include studio.h. Is it the name of that's the name of the header file? They're just including another file. Let's see. I assume that's right. We can learn that later. Right. go back to the other ones. Right, because this is why we joined. This right here is why we joined the lecture. We needed all this data, all this information. I just like just want to have some clarification on some things too to bring down the stress. Right, so this right here we can remove. Well, you know what pragma once does. Okay. This right here, we want to put a plus sign right there. And a plus sign right here. Then do this. It'll show we have declaration, condition statements, right? So let's just see what we know so far. Let's see, class submission. I'm going to talk about this. The information above is important data for the student, aka lecture, blah blah blah, space there, come here, class submission, it's a class submission, right? We're not changing that. We're smarter than that. Copy. Put that there. Dude, why is it like that? You can do this? What the heck? I like that. I love that actually. Alright, Biffers. Alright, brother. Alright, brother. Okay. Your Majesty, please come on in, my man. I'm feeling my death here. Okay, alright. We're gonna do this. Oh my god, I'm too lazy. Yo, could you just please tell me it's this? Oh my god. Great.
Hello everybody. I just want to take a few moments to show you some cool features in the Visual Studio Editor that will make you a lot more productive. Let's dig in. If I want to duplicate a line, I simply hit Ctrl D. And if I want to delete a line, I hit Ctrl Shift L.
Okay, let's try this. didn't they do that? See? See what I mean? I'm right. I'm right, brother. Alright. Great. Fine. How dare you? How many lines are there? Okay, so we do Control A, right? Control copy. Come here. Can I just... Cool. Now we're just gonna... Cool. Then we're just gonna... Cool. Then we're just gonna... Cool.
Skip to content.
Then we're gonna...
Chat history. You said. Cool, now that you have my code, I want you to ignore all the code below the top portion of the said software code. Now you see comments, we must follow moral obligations and I do not want generated code. I want instruction for when my teacher is offline, therefore my instructor will take the L on this. And you shall have his name, however it must be spelled backwards because this is an artist at work showing you the passion of Christ in coding. Now their comments, I want to go line by line and I want you to give me only one sentence for every line, make the lines as short as possible. But if you refer to the line number then you do not show the code, therefore show me the sentence, and what is on that line, and if on that line there is 1 to 10 amount of other lines that need to be understand for me the student to understand said line from top down of the software.
Supposed to be understood.
ChatGPT said. Absolutely, let's get to work artistically and methodically line by line, sentence by sentence. Please upload or paste the top portion of your code here, the part you want me to work on. Since you said to ignore everything below the top portion, I'll stay strictly within the section you provide.
Good, saves data.
Once you share that section, I'll
my ears.
interpret each line with a short, one-sentence explanation. Include what is actually on the line. If that line depends on other lines to be understood, I'll note that too. Avoid code generation completely.
Thank you, thank you. More
and refer to your teacher, respectfully, as Rutsitni. Just send the code when you're ready. You said. Hashtag pragma once. Hashtag include. / developer focus software. / asterisk. Asterisk this is the file where all your work should go. Asterisk this lab is not interactive, that means there should be no. Asterisk calls to input or output for the user. Asterisk. Asterisk info about the lab. Asterisk.
I don't like that.
Asterisk the goal of the first part of the lab is for you to.
That's a tongue twister.
Asterisk demonstrate your understanding of, plus selection. Asterisk statements plus. This means that each test. Asterisk in the first part of the lab will require you to use. Asterisk either a switch or an if statement for all solutions. Asterisk. Asterisk in the second part of the lab.
I'm gonna blow my brains out if I listen to another one of those. So what we're gonna do is we're gonna delete that, and then we're gonna come over. Oh my god, it's 5 p.m. Jeez, brother, we're closing that. Oh, now where were we? So we're gonna post this here. Then we're gonna scroll down. Then we're just gonna. Actually, better yet, because we're smart. Line 1 prevents the file from being included more than once during compilation. Okay. Line 2 include string. What's the code used to standard string by including the string library? A comment made by marking the purpose or origin of the file. Making the purpose or origin of the file. Yeah, essentially. It's 5 to 31. Oh my. Okay. When below the lines, for example, when referring to lines 5 to 31, the block comment, which, if I am understanding you correctly, you are basically just referring to the squiggly brackets. Which the main block portion of the code the developer writes or types. Anyways, put the sum of how many lines in total magnitude so absolute value wise. Post the home sheet again. Wait. Oh, right. Find this block comment. Thinking a block of code. Like right here. Because, we scroll up. These are the first 3 lines. And then we skip 4 because it's white space. But we're going to leave that there. We're not going to change any of this. That's line 5 to 33. It's actually 5 to 33, so we're actually going to change that, I think. Right? Yeah. Well, no, we'll keep it. The entire block explains the roles and purpose of the lab. Not code, so we treat it as documentation. Right, we already know this. Inform the student this lab is about if/switch condition statements, method creation, and clean code practices. Right, which is exactly why we need to join this instructor. Dependencies none, but it frames all that follows. You said what? Hold on. Methods manipulation of more terms. Fine. Credit selection. Call that method in the related test. Okay. Right. Another comment starts in lab credits is key for filters about. Right. 33. Class submission. Right. Okay, so now we're on class submission. Defines a class name submission that holds all methods. with a tab. Okay, do this. We don't want to do that right now. We'll save it though. Okay, we're gonna just read this. Our way. Another time. Okay, so if I holy shit. Okay, let's do this. Ooh, I need food, brother. I need food. Oh, that's interesting. Is it because it's on it? What? I can't do that. Food. No, let's keep it there. point space. No, we're doing it our way. Bro, it's this enough. Okay. We're just playing with our art. So not what I wanted. Okay, here we go. Let's do this. Oh! What was that? Yaw. Okay. I want to save right here. I'm going to do Control A, copy. I want to come down here. This is interesting. I'm not gonna use this for, but like still, like how's it work, you know? It's already helped me a lot, so might as well, right? Ensures the header file is included only once. Okay. Right, enables usage of the std string data type. Right. Your author signature marks code as personal, right? What is this? Okay, so defines a class called submission. We agree. Oh, man. Ugh. What's going on here? Hello? What the hell? And why is input, no sin or see out aloud. Okay. Defines a class submission. Live functions live. Okay, so I want to try replicating this code. Can't not, right? I just need to understand it first. So finds a class. What's mission where you function with? I know. This is start the main block code for the social class. Okay. Right, defines a class called submission where functions live. This is the start of the main block code for the submission class. For the main block of code submission class. Is my logic for platform. This asks my logic outside code with class method dimensions. Okay. This is okay, new class scope enumeration defines symbolic map places with tight safety. Okay. I'll do this. Ooh, I like this. I like this. This is great data streaming right here. On the global and constants means constant integer values as well. Name constants. Name constants are typically else we need food. Let's take a break. Food and coffee. We need food. still streaming. Sure. Let's save this. Let's close that. Oh God. Name constants and names are variables. Wait, hold on. Oh, hold on. Emotions. Okay. Alright, okay.